Hi everyone. In this video, I'm going to explain the linking parameters page, which is common to most of the 2D toolpaths. Clearance is the initial rapid save height. This is the rapid move before the toolpath begins. Use clearance only at the start and end of operation. Uses clearance height only with the first rapid and the last retract move of the tool, not as the tool moves between locations. Retract sets the height that the tool moves up to before the next tool pass. Feed plane sets the height that the tool starts moving with feed rate. Top of the stock sets the height of the material in the z-axis. And depth determines the final loss machining depth. To set the values, you can either click the button on the height that you want to set and select a point on the geometry, or you can enter manually a value. All the heights can be set to absolute or incremental. You can also use the associative option to instruct Mastercam to calculate the values relative to a selected point from the geometry. Absolute means the values are all calculated in reference to the Z0 of the active WCS. Even if the geometry is translated, all the depths will remain unchanged. As you could see, clearance is set up to absolute, so at the beginning it will wrap it up to the clearance, it will wrap it down to the retract value, and because this is a drilling operation, we don't have the feed plane, but from the retract in a drilling operation, the tool will start with feed rate, and it feeds up to the final depth, which in our case is set to minus 1.5. The top of the stock is set to absolute and 0, and you can see that the tool will retract 100 tau absolute above Z0 and then moves to the next hole, and again it will start with feed rate and machines the hole, retracts back to the 100 tau above Z0 and moves to the next hole, and again just drill it, retracts, and at the end retracts back to the clearance level. All the values are set to absolute here. Incremental values are calculated incrementally from the selected geometry or from other depth values. This absolute and incremental values can be mixed and matched in many ways and can have different meanings depending on how others are set. Given the common case where clearance and retract are above top of the stock and depth is below the top of the stock, here is how these settings work. The following diagram illustrates two most commonly used depth settings. This example is for a drilling toolpath and shows tip compensation active. For a drilling toolpath, the retract height is the height from which the tool fits into the material. For other milling toolpaths, that is the feed plane. In the first case, we have clearance set to absolute and 1 inch. Retract is set to 100 tau and incremental. Top of the stock is set to 0 and incremental, and the final depth is set to minus 1.5 and absolute. When the top of the stock is set to incremental and 0, the system considers the top of the stock where we select the holes. We select them at the different Z heights, and the top of the stock set to incremental will be set to those heights. The tool rapids to the clearance height, and then is going to wrap it up to the retract, which is set up to incremental, so it's measured from the top of the stock 100 tau above, and then it's going to feed into the material until it's reaching the final depth Z minus 1.5. After that, it's going to retract up to the retract plane, which remember is set up incremental 100 tau above the top of the stock. It's going to wrap it to the next hole and then wrap it down still 100 tau above the new top of the stock, and then feeds in up to Z minus 1.5. It's going to retract back to the 100 tau above the top of the stock and wrap it to the next hole. Wrap it down 100 tau above the new top of the stock. We'll start with feed rate and machine the hole, and then we'll retract back to the clearance level. It doesn't retract to the clearance level between each hole because we have this use clearance only at the start and end on operation enabled. In the second example, what is different is that we set the depth to minus 0.5 and incremental. You can see again the tool rapids to the clearance, and then it's rapiding down to the retract level, which is set up to 100 tau incremental, and then we'll feed in just half an inch. Retracts back to the retract level, rapids again to the next hole, rapids down in Z only, and we'll feed in from 100 tau above the top of the stock, which was set up to incremental and 0, and then we'll feed in just half an inch. Same thing with the last hole, and then it will retract back to the clearance level. The associative values are calculated relative to a selected point from the geometry. You can use select point to go back to the graphics window and select a point from which the associative value will be measured. This setting is used mostly to reduce unnecessary rapid motion. For example, if some holes in the operations are at the lower step already machined, you do not want to feed the tool from Z0 to reach the holes. Rather, you want to rapid the tool to just above the hole and then feed from that level to the depth. Back in Mastercam, I have a part in which I'm using different options for linking parameters, combinations of absolute values with incremental values, and I'm machining holes that are at different heights. First, I'm starting to machine the counterbore holes, and I'm using for that 3/8 flattened mill. And in the parameters, I have all the settings for the circle milling operation. In the linking parameters, which I'm demonstrating right now, I have the clearance set to associative. And just to show you, I can select a point. And because the clamp height is higher than where I have 0, which is at the top of that face, I can select a point from the clamp, and the clearance will be basically calculated from that point up 1 inch. The retract is set up to incremental. This is the height where the tool is going to retract after machining the first hole. We'll continue to retract to this height between the 4 holes. The feed plane is set up to incremental and 100 tau, and it's going to be based on where the top of the stock is set. In our case, incremental and 0, so top of the holes. And for the depth, it's set up to absolute and half an inch. Remember that you can select the depth if you are not sure what it is by just clicking on the depth button. brings you back into the graphic windows, and if I'm going to turn this part translucent, I can select the bottom of the counter bore like this. Note that I have calculate incremental values from holes lines. This calculates the retract, feed plane, top of the stock values from the top of the hole or a line if it was selected. Okay, for now. And for the next holes, which are all 1/2 inch in diameter, I'm going to demonstrate how you can select them. So I am going to do another drilling operation. In the toolpath hole definition, you can select those holes based on the diameters by holding down the control key and selecting the inside face of one of the holes. Can you see how all the holes that have the same diameter were automatically selected by the system? Okay, for now. Tool, I'm going to make sure that the 1/2 inch drill is selected. In the cut parameters, I'm just leaving the drill counter bore as the cycle. Of course, the peg drill would be preferred in this case. As you can see, we have some deep holes there. I'm going to set the linking parameters, and again, clearance, I can have it selected again from the top of the clamp. Retract, remember in this case the retract is where the tool starts with the feed rate and it's set up to incremental, so it's going to be from where we select the top of the holes 100 thou above, top of the stock 0 and incremental. And for the depth, this time I'm just going to use absolute and select the button and grab an endpoint at the bottom of the part. As you can see, it's minus 3 inches. In this case, I also want to have tip compensation turned on, maybe a small amount for breakthrough, and okay for now. Next, let's check the toolpath in backplot. It starts with rapid movement to the clearance, which was calculated using the associative option. From the top of the clamp, it's set 1 inch above. And I'm just going to go step by step through the toolpath. After clearance, it's going to wrap it down 100 thou above the top of the hole. That's our retract height. And then it's going to machine the hole. It's going to add to the depth the tip compensation and the breakthrough amount. And again, if I just go step by step, it's retracting to the clearance and moves to the next hole. It's going to wrap it down again 100 thou above top of the stock, which in that case is actually the bottom of the counter bore. It's going to start with the feed rate and it's going to again retract. It's following the same steps, basically starting with feed rate just 100 thou above the top of the stock, which is the top of the 1/2 inch hole. It's machining the rest of the hole. It's kind of jumping all over. We can sort the holes afterwards to be more efficient. Okay. So this is basically a combination of absolute values with incremental values and associative option. To optimize the order in which the holes were machined, you can click on the geometry, and there is a sorting option here. I prefer to use the point-to-point one. And for this one, the system is going to prompt you to select where you want to start from. I'm just going to pick this hole, and now you can see the order in which the drilling will be performed. Yes, it's more clean as it is right now. Okay for now. And of course you need to regenerate the toolpath after that. This concludes the video on linking parameters.